Okay, guys, we are going to be looking at attributes from a table and a verbal description today. Attributes from a table is actually pretty simple. The only time it gets kind of tricky is when the attributes are not already in your table. So what I did was I made a couple of tables and I put the graphs beside it so that you can go ahead and identify them. So here's our first table, or sorry, first graph. Again, this guy right here is our x-intercept. Okay, also known as our rocks, and then again that stands for roots, zeros, x-intercepts, and solution. And then we have our y-intercept, which is this guy here. So it's really easy to identify them from a graph. It's just going to be a little bit more difficult to identify them from a table in verbal description. So again, talking about our x-intercept, the coordinates of that is going to be over -2, up 0, and then our y-intercept is going to be over 0, up 3. So here's what I want you to pay attention to. Anytime you're finding your x-intercept, your y is going to be 0. Anytime you're finding your y-intercept, your x is going to be 0. Another way you could think about it is if you're finding your x-intercept, your x should have a number other than 0. And anytime you're finding your y-intercept, your y should have another number right there. So that's just a way to think about it. And now let's take a look at our table. So we're finding our x and our y-intercept from our table. We're not going to focus on slope today because you'll get it in just a second, but mainly focusing our x and our y-intercept. So I want you to find -2, 0 and 0, 3 in your table. So you got this guy right here, and we got this guy right here. So in our table, we have this is our x-intercept. And then this guy right here is our y-intercept. So if you notice, your y is 0 for your x-intercept, and your x is 0 for your y-intercept. So we can come over here and we can write that as our attributes. So y-intercept is our 0, 3. Your x-intercept is your -2, 0. Now the last attribute we need to know from a table is going to be our slope. So let's go ahead and let's find our slope. Now I don't like finding slope with decimals, so here's what I'm going to do. I'm going to come over here and I'm going to look at my whole numbers. So now normally you can go like this for your slope, but I'm going to use my x and my y-intercept. So I'm going to actually find the change in y right here from those guys. So going from 0 to 3 is going to be +3. And then coming over here on the other side, wait for it, sorry. Going from -2 to 0 is going to be +2. So then I can come over here and I can write my change in y divided by my change in x, which is +3 divided by a +2, or just 3 divided by 2. And those are my attributes from our table. So the next one, if we were doing this in class, would be you guys just taking a look at your table and trying to find those values. So I'm going to look at my table and I'm going to find my zeros. So I'm going to find this guy right here, and then I'm going to find this guy right here. Okay, so these are my intercepts. So we know that they're my intercepts because one of them is 0. So you can either think about it like this. Okay, well, this guy, my x is 0, so this one has to be my y-intercept. And then this guy, my y is 0, so this one has to be my x-intercept. You can think about it like that. You can come over here and you can do like a little quick graph. So over 0, down 4. So that guy must be my y-intercept. And over 2, up 0. So that guy must be my x. Again, and just for today's purposes and today's lesson, you can also take a look. You can take a look at your graph. And here we have it just to verify. So we've got our y-intercept over 0, -4. And then we have our x-intercept over 2, 0. Okay. Last but not least, we find our slope. And again, you can find your slope by counting your rise over your run. So I'll show you on the graph just as a refresher. Up 1, 2, 3, 4. So up 4. And then we go over 1, 2. So that's +2. So our slope is a +4 over a +2, or +4 divided by a +2, which is just 2. And again, we can come over here to our table and do the same thing. So from -8 to -6 is +2. And from -2 to 1 is +1. So again, your slope is +2 divided by a +1, which is 2. So again, all of those attributes we're going to list over here on the side. We have our y-intercept, which is 0, negative 4, or you can write it as b equals negative 4. You have your x-intercept, which is 2, 0. And again, there's lots of different ways that you can write it. You can write it as a solution, which is x equals 2. You can write it as function notation, like that, or you have your coordinates. And then we have our slope, which is just 2, or you could have seen it as 2 divided by 1. If you're doing delta math, you have to use that guy right there. Okay, so let's take a look at this guy right here. So again, we're finding our attributes. So let's do an easy one. Let's find our slope. So we're going to go 8 to 10 is going to be plus 2. Let's verify it with our other points. 6 to 8 is also plus 2. Going over here on the left side, 1 to 2 is plus 1, and 0 to 1 is also plus 1. So when finding our slope over here, we have our m equals 2, positive 2 over positive 1, which is just 2. So that's sweet. So we've got at least one of our attributes. Slope is 2. Cool. So now let's go ahead and let's look at our table and let's see if we can find any zeros. So I have this guy right here. I have a 0 here. Boom shakalaka, there it is. So you ask yourself, is that my y-intercept or is that my x-intercept? Okay, if you're thinking to yourself, oh, that's your y-intercept because your x is 0, perfect. That's what I want you to think about. Now we can go over here and we can look at it just to make sure. Okay, here's our y-axis, here's our y-intercept, perfect, over 0, up 6. Okay, so there's our y-intercept, so let's put that up here. Over 0, up 6. Okay, now here's the thing. I don't see my x-intercept in my table at all. So what we have to do is we have to do what's called extending your table so that you can find that x-intercept. So let's refresh ourselves. Okay, if it's an x-intercept, then what has to be 0? Well, if it's a y-intercept, then the x has to be 0. So if it's a x-intercept, then the y has to be 0. Okay, well, let's see if that works. Again, 6 to 8 was 2. What about 4 to 6? 4 to 6 was also 2. Okay, and then 2 to 4 was also 2. So I wonder, is it correct to say that from 0 to 2 is plus 2? Yes, it is. Cool. So another way you can think about it is some number plus 2 is going to give you 2. So what is that number? Has to be 0. So you kind of have to go a little bit backwards with it. Okay, so there's our 0. So if we do that on the right side, then maybe we can do that on the left side. So some number plus 1, because again, over here on this side it's 1s, is going to give me negative 2. So what could that number be? Well, you can also think about backwards. What's negative 2 minus 1? Negative 3. So all we did on this guy is we extended our table and we kind of went backwards. We found our slope, which was plus 2 over here, and we used it to go backwards with it. Then we found our slope over here, and we used it to go backwards with it. So that's how we got our negative 3. So there is our x-intercept at negative 3, 0. And again, you can go over to your graph and you can verify that. Here it is. Here's our 0. Here's our rocks. So our x-intercept is over negative 3, 0. So the big thing with your table is knowing that your x-intercept means that your y is going to be 0, and your y-intercept, your x is going to be 0. So let's not look at the graph on this next one, and let's look at this guy here. If you notice on this table, you don't have any zeros on here. So what we have to do with this one is we have to extend our tables. Now again, we are trying to find our x and our y-intercepts. So again, our x-intercepts, we're going to have a number and a 0. And then our y-intercepts, we're going to have a 0 and then a number. So we've really got to think about the placement of these numbers. It wouldn't make sense to have a y-intercept right here, right? Because you can't go from 2, 4, 6, 8, 10 all the way to 0, right? That just wouldn't make any sense. So that obviously is not going to be where our y-intercept is, but maybe it could be where our x-intercept is. It also wouldn't make sense to have a x-intercept right here on this top part because it's not going to go 5, 4, 3, 2, 1 going down this direction, but then magically have a 0 right here. So think about those things as we're extending our table. But let's go ahead and let's start with our slope. So going from 5 to 4 is going to be -1, and going from 2 to 4 is going to be +2. Let's see if that's consistent here. 3 to 2 is -1, and 6 to 8 is +2. So awesome. So that's pretty consistent with our linear table. So now I wonder if we were trying to, again, we can't make this guy a y-intercept. That's not going to work, right? So maybe if we make it an x-intercept. I don't know why I wrote that like that. Maybe we make this an x-intercept, right? Okay, well, if it's an x-intercept, then this guy right here has to be 0. So I wonder if we continued our slope. Again, 2 to 1 is -1. So what is 1 minus 1? Oh, well, it is 0. Awesome. So we can extend this table by using our slope and still subtracting 1. So this obviously is going to be our x-intercept because I have a 0 in the y. So I wonder what that x value is going to be. So let's go over here and use our slope. Again, 8 to 10 is +2. So let's extend that table. 10 plus 2 is going to give us 12. Sweet, awesome. So there is our x-intercept, and we did that by extending our table. So now the next one that we need to do is we need to find our y-intercept, and our y-intercept is going to have 0 in the x value. So let's look at it. If we are going by 2's on the left side and adding 2, I wonder how we could go backwards with this. So some number, put that some number right here, plus 2 is going to give us 2. So if we're thinking backwards and going backwards, let's take the opposite. What is 2 minus 2? Well, 0. So we extended our table going up, and we noticed that when we subtracted 2 using our slope, we've got a 0 in the x value, which is going to give us our y-intercept. Okay, so let's find that other number. So again, some number minus 1 is going to have to give you 5. So think opposite. Go backwards with it. What's 5 plus 1? 6. Sweet. There's our y-intercept. And all we did was we extended our table. So you can also come over here and you can verify that. So this guy is over 0 of 6. So I left the graph on here to kind of give you an idea of what this would look like on a graph, because you're not always going to have that graph. So let's fill in our information. We had our slope, which was -1/2. We had our y-intercept, which was 6, and then we had our 0, which was 12, 0. And again, you can always write these as coordinates. Okay, let's take a look at this next table. Now, if you notice in this next table, it looks just a little bit different. Notice how I already have the zeros there for you. So we'll just go ahead and write this out here. We'll highlight these because you're looking for your zeros in your table. And then we ask ourselves, okay, so when 0 is in the y, then that is going to be our x-intercept. And then when our 0 is in our x, that's going to be our y-intercept. So now our job is going to be we need to figure out what those numbers are. Now we're going to use our slope to figure that out. Okay, so going from 9 to 3, we are subtracting 6. Going from -2 to -1, we are adding 1. Let's go down to the bottom of our table and verify that. Going from -9 to -15 is -6. And going from 2 to 1 is +1. So what we can do here is we can say, okay, our slope is consistent for our table. Okay, I'm going to get rid of these because they'll be kind of distracting. And now our goal is to, okay, let's fill in the other pieces. Let's kind of go backwards. So here's what I need you to do. Take a look at this highlighted piece here. If I've got my 0 right here, okay, and I go from 0 to 1, that's adding 1, which means it's consistent with these guys right here. So if it's consistent over on the left, then that means that I'm going to have to be consistent over on the right. So if I subtracted 6 here, then going from this number to this number, it's going to have to be subtracting 6 as well. So we think to ourselves, okay, take the opposite. What is -9 plus 6? All right, sweet. That's going to be our negative 3. So again, negative 3 to negative 9 is minus 6. So that's awesome. So here is our first value that we just found. Here is our y-intercept. And again, let's go over here and let's verify that on our graph. All right, awesome. Boom shakalaka. There is our y-intercept. Over 0, down 3. Here's our y-intercept. Okay, now really quick, I just want you to take a look at your graph for a second. Each one of these boxes is a half. So here's 1, here's 2, here's 3. Same thing over here. Here's negative 1, here's negative 2, here's negative 3. So look at where your x-intercept is on here. Now I show this to you because I want you to see what happens with our slope because it's going to work a little bit differently. This guy is our x-intercept and it is at over negative 0.5 comma 0. So let's go ahead and let's take a look at our table. I'm going to get rid of these guys right here so that we can just take a look at our slope. Now, if you notice, looking at this guy, I'll get rid of this too. If you look at just these points, I'm going to get rid of that, sorry. Going from here to here is how far? Well, minus 3. Well, guys, that's different than going from 9 to 3, which was minus 6. So look at that, right? The change going from 9 to 3 is minus 6, but the change going from 0 to negative 3 is negative 3. So it's half the distance of the original slope, right? It's half the distance. So I wonder if we're taking a look over here, and I'm trying to find this value here, then instead of going the whole distance, which is plus 1, I'm going to go half the distance. So I'm going to add a half, right? Instead of going the whole distance, which was plus 1, like this, we're going to go half the distance because going from 0 to negative 3 is half the total distance. So negative 1 plus 5, or plus 0.5 is negative 0.5. And there you have it. There is your y-intercept, or your x-intercept. Just like what we found over here from the graph, this guy matches. So the big thing on this one that I want you to see is that sometimes when you extend your table, okay, when you extend your table, it's not, you have to pay attention to how your table is counting. So for most of these points, it was counting subtracting 6. And this one was adding 1. But when we come over here and we're trying to find those x and y intercepts, it's not always going to be, right? So again, going from 3 to 0, right, is subtracting 3. Subtracting 3, just like that. So just pay attention as you're doing your tables today and looking at how your slope is written. So we've got our m, again, is our negative 6 divided by 1, or just negative 6. And then we have our x-intercept, or our 0, which is negative 0.5 comma 0. And our y-intercept is our 0 comma negative 3. Okay, so let's take a look at this guy. We're not going to look at the graph just yet, okay, but we will verify. So when you get to a table and you're trying to find the different attributes, always start with your slope. So we have our change in y. So negative 14 to negative 10 is going to be plus 4. And negative 2 to negative 1 is going to be plus 1. Let's go down here to some of our other numbers and just verify that. So you got 2 to 6 is plus 4. And 6 to 10 is plus 4. Good. And then we have over here 2 to 3 is plus 1, and 3 to 4 is plus 1. So overall, our slope here is over 4, or 4 divided by 1, and that's going to be our slope. Now, we're looking at our table, and we are trying to figure out, what our x and our y intercepts are. Okay, so let's think about this. We've got our x-intercept, which is a number, comma 0, and our y-intercept, which is a 0, comma 1, or a number. So I wonder if there's a spot on our table where we could put a 0. Well, if we were to continue our table on this side, negative 2 to a negative 1 was plus 1. then I wonder what -1 plus 1 would be. Well, -1 plus 1 is 0. So that's awesome, right? That means that our table continues and we didn't have to change anything about our slope. So if we're consistent over here, then that means we need to be consistent over here. So -10 plus 4 is going to give us that next value. So -10 plus 4 is going to give us a -6. Let's go ahead and let's verify that over on our graph. Boom shakalaka, there it is. Here's our y-intercept, over 0, down 6. And all we did on here was we extended our table, except it wasn't going outside, it was kind of staying on the inside. So here's our very first intercept. Right there. All right, awesome. Now we have to find our x-intercept. So when we do our x-intercept, then we need to be looking at this guy right here, and we need to make sure that our y is 0. So based off of what we know about our table, guys, it's kind of obvious about where we're going to put that 0. We can't put that 0 over here because we've already got a 0 in the x values. So that means that that 0 is going to have to go over here, right? So now let's take a look at the slope from this guy, from -2 to 0. Well, look at it. I'll change colors so you can see the difference here. -2 to 0 is actually +2. And then the same thing going from 0 to 2 is +2. So our slope kind of changed on this one, right? It changed. So if it's changing over here, then we have to make sure that we change it over here. Now, if you look at your numbers, your original slope was +4, and now we're doing +2, which is half of 4. So if we come over here on this side, we're going to have to take half of that 1. So going from here to here, we're going to actually be adding a half, which turns out to be 1.5. And there you have it. You now have found your x-intercept right here. And we can verify that over on our graph. Here we go. Here is our x-intercept. It's in between 1 and 2, which is 1.5, comma 2. Or sorry, comma 0. Perfect. There you go. So we just extended our table. So our slope is 4 divided by 1, which is just 4. And then our y-intercept, we had a 0, comma, -6. And our x-intercept was 1.5, comma, 0. Okay. Again, you won't find this on your table, you'll have to figure that out. So let me show you guys some of the ways that you're going to see this on a STAR test, and I gave you some examples here. So you have an ice machine. It makes the same number of cubes each day, and then here's the table that shows the number of days versus the number of ice cubes. So it says, based on the data in the table, what is the total, Notability crashed, wait for it. Sorry, going back down. Okay. Based on the data in the table, what is the total number of ice cubes in the machine will have made after 7 days? So taking a look at our table, we can do the exact same process. Let's go ahead and let's figure out the change in our y divided by the change in our x. So 260 to 520 is going to be adding 260. I'm sorry. Going from 520 to 780 is still adding 260. Going over on the left side, 2 to 4 is +2. And then 4 to 6 is also +2. So same process, finding our attributes, there's our slope. Now it's wanting to know after exactly 7 days. So the left side of our table is the number of days. So here's what we have to do. We have to come up with an extended table. Oops, sorry. I'm just going to extend this right here. And I'm going to fill this in. Don't judge this. I'm going to fill this in like this so I don't see all of the words, yeah? Okay. So let's extend that table a bit. So let's put this as 7 days, right? And we need to figure out what this number is. All right, cool. So look over on the left side. If I'm going from 6 to 7, that's not going to be +2. That's actually going to be +1. So just like what we did on our table, if this guy is 2 and this guy is 1, then 1 is half of 2. So if we're being consistent, instead of doing 260, which is the whole thing, we're going to have to take half of that. So taking half of that is actually going to be plus 130, not 260. So 780 plus 130 is going to give us 910. So that's going to be our answer. And this is how we would grid this. 910. We come over here. It doesn't matter where you place it. You don't have to fill in your bubble for your plus. You can if you want to. And then we have 910 for our value. Again, it doesn't matter if you put it at the front or if you put it over here. It doesn't matter as long as you bubble it correctly. Okay, the second one we have over here, it says the table represents some points on a graph of a linear function. Which one has the same relationship? Okay, so some people might look at this and be like, oh, Miss Hastings, look, there's our y-intercept because it's 0. Well, that's not true. That is actually an x-intercept, so you have to be really careful with that. But what you can do is you can look at this from a graph, okay? You can look at it from a graph. And so what I would do and what I would suggest is pulling up your calculator. Oh, I'm going to have to go to it, sorry. Desmos, there we go. Wait for it to start. Let's pull it up now here. Pull up the app, bring it over. Okay, and then what you can do is you can start typing in your different values, so your different functions. So you got 5x minus 2.5. Now, it's kind of hard to see because you want your tables to match. So you can click on this guy and you can actually make a table. Okay, so let's take a look. Our x is 1 and it gave us 2.5. But if you look at your table over here, that's not true. So we know it's not going to be our f. So let's get rid of that one. Okay, then we have our x minus 0.5. Oh, we got to put our y equals, sorry. Y equals. There we go. Let's make it a table. Okay, coming down over here to our 1. Our x is 1. Nope, it's not negative 7.5, so we know g is not going to work. Next one. We have negative 5. Oh, I got to do the y equals. I'm so sorry. I keep forgetting that. Y equals negative 5x minus 2.5. Let's make this a table. Oh, look, there it is. 1, negative 7.5. Okay, let's check another one. Let's check 5. I'm going to plug in 5. Oh, look, negative 27.5. So awesome. Our stuff is matching, right? You can also come over here and you can type in negative 1.5 and it gives you 5. So yes, our table matches here. So boom shakalaka, there we go. All right, let's take a look. I'm going to scoot this over a little bit. Let's take a look at our verbal descriptions. Verbal descriptions are super easy, mainly because we already have them listed for you. I am just going to show you how to write it, and then I'll show you how to graph it. So look at this first one. Evan is going to the county fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. If his parents gave him $20, how many rides can he go on? So your job is to first figure out what is your constant and what is your rate. So we have two different things, your constant and your rate. So taking a look at our options, it says the admission was $5. Okay, here's the thing. Your $5 is not going to change. That is your fee, right? That is your entry fee. It's not going to change. So because it's not going to change, we're going to call this our constant. Okay. Now, your rate is going to change. Well, your rate, the amount per ride is not going to change, but how many rides you ride is going to change. So our rate is 50 cents, per ride. So when you think about your verbal descriptions, I want you to really look for these words, like per, right? So per ride, it's 50 cents per ride. So that's going to be my rate. Now, when you're talking about rate, you are talking about your slope. When you're talking about your constant, you're talking about your y-intercept. So as you start to write your equations, your rate will always go with your slope, your slope will always go with your x, and your constant will be all by itself. So let's take a look at these guys here. So that 50 cents should be per ride. We don't know how many rides there are. And then it's going to have to include your $5 fee. So this guy is going to be our correct value. Now let's go ahead and let's graph this. Y equals 0.5x plus 5. Okay. So here it is graphing 0.5x plus 5. Now the reason why we have to graph this is because we've got to answer this last question. If his parents gave him $20, how many rides can he go on? So if he gave him $25, how many rides can he go on? So coming over here to our stuff, I'm going to go ahead and I'm going to hit a table. Now, we don't need to know all of the negative values because you can't have negative rides. So starting here on our graph, starting 0, if he rides 0 rides, then it's going to be $5, right? So we want to figure out how many rides he can take with $20. So right now, if he rides one ride, okay, one ride, he spends $5.50. If he rides 2, he's got $6. So what about if I rode 10 rides? If I rode 10 rides, then I spent $10. Okay, what about 15 rides? $12.50. What about 20 rides? 20 rides, he spends $15. Interesting. What about 30 rides? Oh, look, guys. Over here, we've got 30 and we've got 20. So he spent $20 and got to ride 30 rides. So I wonder what that would look like if we zoomed in on our graph. So look at this up here because this is really important. If you looked, our x's were our number of rides, right? And then our y's was our that was our amount, our money. So if we were taking a look at our graph and I wanted to figure out how many rides I could ride, then I would be paying attention to our y-axis. So here's our point. If you were given $20, that would be the y-axis. So I would go up to my y's, up to 20, and then I would figure out where my line was. So just like our function notation from a graph. So that gives us our 30 and our 20. So then coming over here, my solution would be 30 rides. You can find this from a table or you can find this from a graph. But again, you're just looking for where your y was 20. Let's take a look at this next one. All right. While visiting Crimson Lake, Sally decided to go kayaking. The rangers charged $8.50 per hour in addition to a $25 deposit to rent the kayak. If she rented the kayak from 11:30 a.m. to 2:30 p.m., what is the total cost to rent the kayak? So let's think about this. What is your rate? So we find the word per, and here it says hour. So we're going to be using our rate as $8.50. So there's our rate, $8.50 per hour. Now, this is your slope, okay? That's your rate of change, and it has to go with your x. Then it says an addition of $25 for the deposit. That $25, guys, is not going to change. So that is your fee to rent the kayak. So that's not going to change. So that's not your slope. So in writing this, okay, your $8.50 has to go with your x because your slope always has to go with your x. And your $25 is going to be all by itself. So we're going to be choosing our B. Let's go ahead and let's graph that. Y equals 850x plus 25. Awesome. So here we go. Now here's the thing. No matter what, you're automatically starting with a $25 fee. So that's going to be this guy over here. So we're not going to focus on that point right there because that's your starting fee. But the solution to this is wanting to know how many, or like what the total cost would be. So if I'm going from 11:30 to 2:30, so you've got 12:30, 1:30, 2:30, that is 3 hours. Okay, that's 3 hours. So you can use function notation for this if you want. You can say, okay, well, $8.50 times 3 plus 25. Okay, well, that can give me my value. You can also come over here and you can look at a table. Okay, not looking at our y values, right? And not even looking at our negatives, because you can't have negative hours, right? Time can't be negative. So I wonder if I came over here and I plugged in 3 hours. So then we would have this guy over here, $50.50. So the other thing you can do, this one's a little bit harder, is you can look on your table and you can figure out your 3, so over 1, 2, 3, and go up to your function, all the way up, all the way up, all the way up, keep going, keep going, keep going, keep going, keep going. Oh, right there, 3, 50.5. So this is going to be our solution. So it would cost $50.50. And again, that was coming from this. All right, last one. Here we go. If you buy a car wash at the gas stations for $6, the cost, oh look, per gallon is $2.35. How many gallons of gas can you buy if you only have $40? Okay, well, let's think about this. It says cost per gallon is $2.35, so that's going to be your rate. So $2.35 per gallon. And then it says $6 for your car wash. So guys, the cost of your car wash is not changing. That's why it's the constant. So let's take a look at this guy. Your constant is always going to be by itself. So boom shakalaka, there it is. We're going to be using that equation. So let's type that in. Y equals 235x plus 6. Awesome. All right, so let's take a look at our graph. Our graph is way down here. Okay, I'm going to zoom out a little bit. So no matter what, we've got this guy right here. That is your starting cost, right? After that, getting no gallons of gas. So we want to look at it and we need to say how many gallons of gas can you get if you've got $40? So on our table, this 40 is going to be on the y-axis because that's our money. So I'm going to actually go up to my 40 over here. Here's this initial piece right here, sorry. And I'm going to go over to my function, which is right here. Oh, I can't, it's not letting me click it, sorry. Oh man, sorry. I wish it was letting me click on it, but it's not. It's right there. Oh, I want it to be 40. It's not happening. Okay, sorry. Sorry. So our gallons of gas is going to be up here at 40. So that's going to be kind of around 14 gallons, right? Around 14 something. So let's pull up that table. Okay, so this is not going to really help us, right? So let's plug in a 14 over here. 14 gallons would be $38.9, and let's do 15. What about 15? But 15 would be too much. Let's do 14.5. Oh, 14.5 is not quite there, right? And then what about 14.45? Oh, close. Let's do 4.6, almost. 4.7. So we're getting closer, but let's think about this. If we're talking about specific gallons of gas, because we want to know how many gallons, right? Let's do gallons as a whole number. So if I only have $40 and I can't go over and do more than that 14 gallons, then we're going to stick here at our 14. So we can get approximately 14 gallons of gas, okay, without going into that next spot. So we're going to say 14 gallons. Now I know gallons of gas can have decimals, so approximately without going over, right? Without going over, we would probably have to stick with our 14.35. Let's do 40. So about 14.4 gallons of gas, but we're going to stick with our 14 to keep it a whole number. So what you guys are going to do today is you're going to be looking at your verbal descriptions, okay? And you're going to be filling these guys in. So this is what it's going to look like when you do your assignment today. It says Jack starts a savings account with $5 and adds $10 per month. So look for the words per. So there's going to be your rate. So you're going to write $10 per month. And then you're going to find your constant, which is going to be the number all by itself, which is $5. So that's how much he starts it with. Now scroll on down to the very bottom, and then you're going to pick from one of these options here. So it's either going to be A or it's going to be B. Now again, he started with $5 and put $10 each month, right? Starting with $5 and $10 per month. So we're going to be choosing answer choice A. So let's go back up here and let's write that. So we have our y equals, 10x plus 5, and that's going to be A. Now what you're going to do is you're going to come over here to your calculator. And you're going to type that in. Y equals 10x plus 5. Now this next part right here is just wanting you to find your rocks. Okay, so let's take a look at this and let's find our rocks. So our rocks is our x-intercept. So in this case, our x-intercept is over negative 0.5 comma 0. Okay, looking at the next one, we have a fish tank is full of water. It has 8 gallons and begins to drain at a rate of 2 gallons per minute. So our rate is 2 gallons per minute, and our initial value, our start, is 8 gallons. So our rate, 2 gallons per minute, and it starts with 8 gallons. Now here's the thing, it's draining, guys. It's leaving the tank. So when we take a look at this one, we are not going to have any addition. Okay, we're not going to be adding to it. We're actually going to be subtracting it. So the way I would originally write it would be 8 minus my rate, right? But you're never going to see it written like that. So we're actually going to see it written like this. Okay, so we're using our answer choice C. Let's come over here and let's write that C. So we have y equals negative 2x plus 8. So we have y equals negative 2x minus 8. Now if you look at our graph and we're finding our x-intercept, finding our that should be plus, my fault. There we go. Finding our x-intercept, it's this guy right here. So our x-intercept is over 0, 4. Now what does that mean in our situation? Well, if our rate was 2 per minute, then this 4 right here means 4 minutes. So it took 4 minutes to empty that tank. Okay, you guys, so here's going to be your assignment for the rest. You're going to complete all of these guys right here. You can utilize our answer choices down at the bottom.